Now, I want to mention a few properties of the standard deviation. The first one being that the standard deviation is always equal to a positive value. Let me refer back to the example we did together. Whenever you square a value, you're going to get a positive value. So the square deviations are all going to be positive. When we add all those positive values, we get a positive value. To compute the standard deviation, we have the square root of a positive value divided by a positive value. N minus 1 is always going to be positive. The square root of a positive value divided by a positive value is equal to the square root of a positive value. The square root of a positive value is equal to a positive value. Your standard deviation should always be a positive number. Now, if you end up with a negative value, you know that you made a mistake. So again, the standard deviation is always positive. Now, the standard deviation can be equal to 0 only if all the data values are exactly the same. So for example, let's say your data set is 5, 5, 5, 5, 5. If you find the standard deviation of this data set, you're going to get 0. Now, another property that I want to mention is that the standard deviation can increase dramatically if there are one or more extreme values in the data set. Remember, extreme values are also known as outliers. Let me remind you that we use the mean to measure the center of a data set if we don't have any extreme values. If we do, then we use the median. It's going to be similar with the standard deviation. If you see that you have extreme values, you're not going to want to use the standard deviation. Why? Because the standard deviation is affected by extreme values. You can think of it this way. If you don't have any extreme values, then you can use the mean to measure the center of the data set, and you can use the standard deviation to measure the spread of the data set. The last property that I want to mention here is that the standard deviation is expressed in the same units as the original values. Let me give you an example. If the data values represent a measurement in inches, then the standard deviation is going to be a value in inches. The standard deviation is going to have the same units as the original value. Now, let's talk about how we can use the standard deviation to describe a data set. The standard deviation can be used to measure how far a data value is from the mean. And to do this, we're going to use what we call a z-score. A z-score is the number of standard deviations a data value x is from the mean. To calculate the z-score, we use the formula here below. Here, z represents the z-score. The z-score is equal to x minus x bar divided by the standard deviation. The value that you get for the z-score is the number of standard deviations x is away from. If you have a positive z-score, then that means that the data value x is to the right of the mean. A negative z-score means that the data value x is to the left of the mean. Okay, so let's go ahead and practice this using the example here below. Consider the data set with a mean equal to 24 and a standard deviation equal to 5.5. Here we can assume that we're talking about a sample. So when we read that first sentence, we can go ahead and write x bar is equal to 24, s is equal to 5.5. Okay, again, here we're going to assume that this is coming from a sample. That is why we're using x bar and s. If we were being told that we have the mean and the standard deviation for the population, then we would write mu is equal to 24 and sigma is equal to 5.5. We're going to assume that this is coming from a sample. So that is what's given on the first sentence. Now, determine the number of standard deviations. The data point 32 is from the mean. That second sentence can be rephrased as find the z-score corresponding to x equal to 32. And so let's look back at the formula for finding the z-score. Z is equal to x. In this case, we have x equal to 32, so we're going to write 32, minus x bar. Here, x bar is 24. Then we need to divide by s. S here is 5.5. So here, the last thing that we need to do is we need to enter this on the calculator. If you're going to do it all in one line, you're going to need parentheses on the numerator because you want to subtract before you divide by 5.5. You can also do this in steps. 32 minus 24 is 8 divided by 5.5, which is equal to 1.454545 repeating. So I'm just going to go ahead and round to 2 decimal places. Here we get 1.45. Let me go ahead and help you visualize what we're seeing here. I'm going to draw a number line. The center of the number line is going to be x bar equal to 24. Now I'm going to label the first standard deviation to the right. To label that first standard deviation to the right, I need to take 24 plus the standard deviation. 24 plus 5.5 is 29.5. If I want to label the second standard deviation to the right, I need to add another standard deviation. So I need to take 29.5 plus 5.5. That gives me 35. I could also label the third standard deviation, the fourth standard deviation, and so on. I'm just going to go ahead and stop at the second standard deviation. Now, you could also label the standard deviations on the left-hand side of the mean. To do that, you would take 24 minus 5.5. That gives you 18.5. That is the first standard deviation. 18.5 marks the first standard deviation on the left. You can go ahead and label another standard deviation to the left of the mean. For that, you need to take 18.5 minus 5.5. You should be getting 13. And I can label another one. If I want to label another standard deviation on the left, I take 13 minus 5.5 and so on, which is between 29.5 and 35. I'm just going to go ahead and label it here. The z-score, 1.45, is telling us the number of standard deviations x equal to 32 is away from the mean. And that is what we're seeing on our number line. We are about 1.45 standard deviations away from x. If you want to describe how far a data value is from the mean, you can go ahead and use a z-score. Now, I also want to show you how you can find outliers, also known as stream values, using the standard deviation. So let's write the standard deviation can be used for finding outliers or stream values. And here's the rule. A data value that is more than 2 standard deviations from the mean is considered to be an outlier. In other words, if a data value is greater than x bar plus 2 standard deviations, that is x bar plus 2 times s, then it is an outlier. If a data value is less than x bar minus 2 standard deviations, that is x bar minus 2 times x, then it is an outlier. Let us use the number line here below to visualize. In the middle, we're always going to label x bar. Now, if we wanted to label one standard deviation to the right, then we would take x bar plus s. If we want to label one standard deviation to the left, then we take x bar minus s. That is the first standard deviation to the left and right. If we want to label the second standard deviation to the right, we take x bar plus 2s, or 2 times x. On the left, if we want to label the second standard deviation, we take x bar minus 2 standard deviations, that is x bar minus 2s. The rule states that if any of your data values are less than the second standard deviation on the left, or if any of your values are greater than the second standard deviation on the right, then those are going to be considered outliers. This is where you're going to find the outliers. Okay. So let's look at the example above. Looking at the number line that we have here, let me erase here. Let me also highlight where we would find outliers. We'll find them below 13 and above 35, right? That is below the second standard deviation on the left, above the second standard deviation on the right. So if we're looking at x equal to 32, is x equal to 32 an outlier? The answer is no. X equal to 32 is within 2 standard deviations from the mean. Now, what about something like x equal to 12? Well, x equal to 12 is below the second standard deviation on the left. Thus, we would say x equal to 12 is an outlier. Now, with that being said, I want you to go ahead and consider the example below. In exercise number 5, you're being asked to determine if there are any outliers in the set of the following 13 real estate prices. So you have 13 data values. In order to determine if you have outliers, you're going to need to compute X bar. You're going to need to compute S. You are also going to need to compute X bar minus 2 times S. And you're going to need to compute X bar plus 2 times X. I'm going to show you how to use technology to find X bar and S. We're not going to do this by hand. We're going to do it using technology. Using a TI-84 calculator, we first need to enter the data values. Now I'm going to enter all the data values under L1. Our first data value is 389,950. Enter the value and then press enter. Go ahead and do this on your own. Enter all 13 real estate prices. Once you're done entering the data values, make sure to go back and check all the data values. It is possible that you made a mistake when entering those data values. Now we're going to press on stats, press the right arrow to go under calculations and click on the first option. Here we have one variable and we're wanting statistics about that variable. Press enter. I have the data values under L1. If you have the data values under another list, go ahead and edit. I'm going to keep it the same. I'm going to go down. I don't have a frequency list. I'm going to go down to calculate. Press enter. And there you have it. You have the value for X bar. Now here below, you see the value for S and you see the value for sigma. S stands for the standard deviation of a sample. Sigma stands for the standard deviation of the population. Here we have a sample composed of 13 real estate prices. We want the value of S. Let me show you how to find X bar and S using Google Sheets. First, you're going to need to enter all the data values on a separate cell. Here I decided to enter the data values on a row. You could also enter the data values on a column. To find the standard deviation, you need to click on an empty cell, enter equal, and start typing ST. I'm going to stop there because I see the option to calculate the standard deviation. The function here is equal STDEV. Okay. Click on that option. Now you need to highlight the data values. Let's go ahead and highlight all the data values and then close the parentheses, click enter. And this is your standard deviation. This is your S value. Now we also need to calculate the mean. I'm going to click on an empty cell, type in equal, and start to type average. It's going to be the second option here, average. Go ahead and click on that option and then highlight all the data values. Once you highlight all the data values, you should close the parentheses. Press enter. And there you have it. You have your X bar. You're going to need these values. Go ahead and copy them into the activity. When we copy those values into our activity, we're going to make sure not to round because we have more calculations that need to be made using those values. Remember, you should only round when you arrive to your final answer. Okay. Now we need to find X bar minus 2 times S. Let's go ahead and write this expression. Write the value of X bar minus 2 times the value of S. Go ahead and enter this expression on your calculator. You should be getting negative 1,965,551.471. It's a little hard to read without the commas. So here's what we have in mind. We can picture a number line. At the center, we have X bar. We are finding X bar minus 2 times S. This value is negative 1,965,551.471. We know that if we have any data values below this value, those are going to be considered outliers. Now, let's go ahead and calculate X bar plus 2S. Write the value of X bar plus 2 times the value of S. Go ahead and enter this on your calculator. You should get 3,695,582.241. And so on our visual, we can go ahead and include that value. Here we're calculating X bar plus 2 times S. We found that value to be 3,695,582.241. If we have any data values greater than x bar plus 2s, they are considered to be outliers. Now, below this video, I'm going to include a question where I'm asking you if any of the data values are considered to be outliers.